So let's take a look at another type of display for a quantitative variable, and that's the box plot. Okay? To get us going, we want to take a look at some of the vocabulary. The first vocabulary we want to look at is the words that have to do with its variation and center. So the range here is going to be a number, a single number. We don't say from and to, which is typical. Like a lot of times we say our data ranges from this to that. A range in stats is a single number. So you take the maximum and subtract the minimum. So if it was 200 minus 20, then our range would be 180. Okay. The quartiles, this is a very fun word, but if you recall, the median is that very center number, the number in the middle. Well, now we take the middle of the lower half and the middle of the upper half created by that median, and we get the quarters then, so to speak, and so these are called the quartiles. So you can see in the graph here that we have quartile 1 and quartile 2 is that median, and then quartile 3 and going on to the max. So we have 4 sections is what we end up to. We just refer to them as Q1, Q2, Q3. We don't usually call it Q2 so much because of median being that Q2. And since we're looking for what is the most typical data, and an important section of this box plot is called the interquartile range. This is kind of like the middle section, if you will. So we're going around the median there, and so from Q1 to Q3 is called the IQR, the interquartile range. We just call it the IQR. So you take, again, it's a number, not this from and to, so you do Q3 minus Q1 to get that range, that number. Okay? And so we end up with a 5-number summary to describe our box plot. You have that lowest number, your minimum, and you have your highest number, your maximum, being the 2 end pieces there, that end of your whiskers, if you will, call them whiskers. I tell the students that when they were in middle school, we used to call it a box and whisker plot, and now we got to high school as a box plot, so we were more sophisticated. But and then you have your median that we're used to, that middle value, and then now you have that Q1 and Q3, and we also call that Q1 the lower quartile. That goes between the first quarter and the second quarter, and then you have Q3 being the upper quartile, going between Q3 and Q4. Okay? So what does this have to do with spread? Because we start talking about the spread of our data. Well, if this data was evenly distributed, then these 5 numbers would show us consistent intervals on the graph. Okay? But if the data is clustered, or as you can see here, not evenly spread, this one's not quite evenly spread. It's not too bad, but it's not very even. Okay, then if we have some sections where these numbers are closer to each other than others, like right here, we see Q2 and Q3 are much closer than Q3 and the maximum. Okay, then we could see that we have some kind of a spread. More on that in just a second. Okay. So the first thing we always talk about is having students practice on paper first, and so we do have an activity where they will practice on paper by looking at 2 family reunions. Just noticing and wondering the data, that obviously you take a look at this and we see the Watson family. Whoa, man, the kids kind of crack up at this one and think, oh, that is nobody, either that family is already quite old or dying up, or nobody could come. They were all at work or something that were in the younger part of the family. We don't know the reason, right? But we want to start making the 5-number summaries for them. And so, of course, you need to put them from least to greatest. And they put down that and begin to find the 5-number summary. Here I've done the range for us by subtracting maximum minus minimum and finding the IQR for us. But they'll create that on BoxPlot on paper and take a look at that when they've got their 5-number summary and have created their Q1s, their Q3s, and here's what they will look like. They'll compare and contrast and have a discussion then about the differences here. this is where box plots are really powerful, is when you do contrast two data sets. It's really powerful when you see them stacked like this. You can see very clearly the differences in the ages that are there. And you can see the median age for these families is quite different. They could see the minimum, of course, being quite different, and have some discussions with that. Okay? So let's return to investigating the shapes of them. In general, we've talked about shape when we were in histograms with that left skew, the symmetric, and the right skew. So we're going to return to that now with box plots. And just take a look. If it's left skewed, they will have either a longer whisker and or box on that left side. Right skew will be the same thing, but with the longer whisker or box on the right side. Whereas symmetric, you have that median in the middle, and it'll be basically the same distance to the left and to the right. When you fold it, they'll be the same amount of variation on the low end as on the high end. And so I've got some samples of each symmetric. Just as in histogram, we had some different looking histograms that were symmetric. Same thing here with your box plots. These are all symmetric box plots, where you could fold them and they would be very similar on each side of the median. Just as with histograms, we don't just talk shapes, we need to talk context. And so I've given us some context down here. The weights of cousins in a family with the newborn as an outlier. So a newborn might then pull down that whisker on the left in. I apologize here about this, that the weights of newborn babies, so you have basically most babies are about the same, and you have some that are premature and might be smaller, and then you have some that are large. My brother was 10 pounds 11 ounces, so you get some that kind of come in on the larger side of that. Poor moms for those, right? The right skew, you have here high outliers like Simone Biles with her floor routine when she went so high in the Olympics that we just recently had. Giving them some context for the shapes. Oops, sorry about that. And then move on to Pirate. And now let's put the contract into Pirate, and it's a pretty simple one, just the table and the column. And then they do it for pounds and say, wow, see, now we can look at this and see that pretty right skewed shape there. And do we think that this is really the mean that we got was really the best measure of center for us? And then I just threw some analysis things that would come up here, like the heaviest 25% of animals ranged from, well, where did I get these 60.4 and 172? From your 5-number summary, which is given at the top of your box plot charts. The 5-number summary will be found in Pirate's charts. And 25% of the animals weighed less than 3.9 pounds there. So each one of these sections of the box plot holds 25% of your data. So you can see this is dense, very dense, whereas this is more spread out. This is where we get that word spread. The spread of the data is quite spread out. This is because we have these outliers of those heavy dogs. Cujo and Mr. Peanut Butter are pulling that, skewing that whisker further out, whereas we had all those little animals over here on the left with those snails and bunny rabbits. Oops, that's crazy. Most of the animals weigh far less than that average that we had been looking at in the animals data set of 40 pounds. So that's probably not a good measure. I just tossed this in here. This will be found in the box plot lesson, but just for you to be aware of, there are additional box plot functions out there for you to contracts you can go and look at. If you are a stats teacher, you know the modified box plot puts dots out where there are outliers, and I circled the outliers out here. So that you can clearly see if it is an outlier. In stats, there is a formula for you to go to find out if it's exactly an outlier or not. There's a fancy formula for that. And so there it is. It's right there. So they have modified ones. We have a way to do it scaled. So especially, you know, those ones that we were just looking with those reunion families, if you want to stack two on top of each other, you would like to make sure that the scales are the same when they're printed so that they would stack the same. So you could go put the scale and make sure you put the low end and the high end number, and that way they would come out exactly the same for you to put one on top of the other when you're stacking them. We also have, and that's what I put here, you could set the scale yourself. Okay? Here is the vertical, if you want it to go vertical instead of horizontal. They're there. So those are just options for you. But why teach box plots in the first place? I tell my students it's really important that you have two eyewitnesses here. Okay? You're trying to tell the data story. That's the whole thing we're doing here. We got a bunch of data. We want to tell the story of what's going on with this data, right? And just like if there was a crime that was committed, you know, the police or the attorneys, whatever, are going to try and get as many witnesses as they can so they can tell the story, because some people see things that others miss, etc. And so you've got the box plot and the histogram. They kind of tell two different parts of the story. And it's really important to put them together because then you get a deeper, richer story. So make sure that when you're teaching this, that they get both of them. I feel they should do both. Don't skip them. A lot of teachers want to skip box plots because they don't understand them or they haven't taught them before. I feel that you need to jump into it and put them together, right? What does a box plot do? Well, it gives you that exact minimum and maximum and median. You don't get the exact in a histogram. You get about where it falls, but you don't know exactly what it is. It's in a range of a bin somewhere, okay? You have a clear picture of that spread. You see that spread very clearly in a box plot, right? But a histogram does give you that shape. You can get it as granular as you need it to be, but based on changing your bin size. You see the gaps. The gaps are not evident in a box plot. They don't give you those, but a histogram does. And you see the peaks more. Where is the data peaked? Those kinds of things are not seen in a box plot. So being able to see both together, very, very powerful together. So be responsible and give a complete picture to your audience, right? And so this chart, it will be in the slides for the students and in your lesson, but here's the differences between box plots and histograms. They're what they do differently. You know, the intervals for a box plot will vary depending on 25% of the data, how far it goes there, but that the number of points per interval is fixed at that 25%. Whereas histograms, you fix the bin size. It's 20, 20, 20, you know, all the way across. But then the number of data points in each bin, it varies, depends on how many data points fit in that bin, right? The skew for a box plot will be that whisker or box. That's how it's spread. And the skew in a histogram will be that tail coming out of the bars shorting off to one side or another, right? And I just put a connection down here. These are the box plots and how they connect with a histogram, and the students will go through and do a worksheet and match box plots to histograms. There's Desmos activities for them to do that as well. But for example, you could see right here how the box plot shows this in this second one here, the spread in the center, that it's really spread out, and yet it's very dense and condensed here on the ends. And so that's why this one matches with that histogram there, etc. You work through those. 3 closing ideas that you could do. Here's where you could return to that histogram poster if you watched the histogram video, or there was a poster idea there where students are now in groups around the room, and they have the shapes have been on the top of the posters, symmetric, skewed right, skewed left, and they have done 2 of the shapes already by drawing a histogram of that shape and then rotating to the next shape and doing a scenario. And now they should rotate to the 3rd shape that they haven't done yet and draw a box plot that will match the histogram and the scenario that has been prepared for them by previous groups. Those posters are excellent ones to leave around the room. Go to that data exploration template project that you have started and make sure they add the box plots that they have created from their chosen data sets to it. And then there are now checkpoints sprinkled throughout the box plot lesson. I think there are 4 of them now, and you can use those as assessments along the way, or you can use them all as one closing idea, one closing assessment. I have, if this will let me get out, it's not letting me get out. There we go. Just they're here, former assessments in the Desmos, and there's all the questions there that they can work their way through. So enjoy the box plot lesson. It's a great one. Don't skip it.